So hello students, today we will be discussing some new topics on class 10, standard 10, that is class 10, so on the basis of MBSc course, okay. We will be discussing on the MBSc course, that is subjects is mathematics, okay. We are going to discuss on the mathematics chapters, okay. The subject is mathematics, okay. So here's I will be dealing on the, first of all I will be dealing on chapter 2, this is from chapter 2 we have algebra chapters, okay. Algebra chapters, that is chapter number 2, 3, 4 and 5, and this is a section where you can score good marks, okay, and it also consists of the highest marks in this in terms of mark distribution in terms of MBSc guidelines, okay. So first of all we will be discussing the chapter number 2, okay. Chapter number 2, that is our chapter number 2 is what? It is a polynomial. What is it? Polynomial. Do you know what is polynomial? Okay, so polynomial mostly defined in, as you have learned in class 9 or so. Polynomial mostly defined by this section, that is px. Okay, polynomials of x, that means polynomials of function x. That means x is the function, the equation that have been given depend on the values of x. Okay, now if I write this polynomial px, okay, px is equal to, let's say, a1 plus a2 x to the power 1, a3 x to the power 2 plus a4 x to the power 3. Keep on going, okay? So keep on going, an x to the power n. So this is what we express this as a polynomial. Polynomial means that the term is that poly means many, mial means terms. Okay, here you see how many terms we have: 1, 2, 3, 4, 5. There is a continuous term that is keep on going. Okay, so here we have more than 2 or 3 terms, So such types of equations are called as polynomials. Okay, such type of equations are called as polynomials. Okay, such types of equations are called as polynomials. Now you see, degree of the polynomial, we are going to discuss about the degrees of the polynomials. Okay, so degree of the polynomial based on the degree. If the degree, let's say our polynomial degree is 1 or degree is 0. Okay, when your degree is 0, if the degree is 0, that means the power, okay, the power is 0, that means this is always a constant number. This is always a constant numbers. Okay, this is always a constant numbers. Okay, this is always a constant numbers. If the degree is 0, that means it is a constant number. That if I talk about a to the power 0 is 1, or x to the power 0 is also 1, or y to the power 0 is also 1. Okay, so if I write this one 5 into a to the power 0, that means it is 5. Why? Now this 5 is the constant number, so this one here, your power degree of the power is what? 0. Here our degree, if I write this one as a 7x to the power 0, here you see our degree is 0, then this value is also 7, and this 7 is what? Is a constant number. Okay, if the constant number, for the constant number the degree will be 0, and in terms of polynomial we discussed there, the degree, the highest degree of the constant number is always 0. The highest degree of the constant number is always 0. Okay, now if I talk about the degree of the polynomials of the linear equations, next, if the degree is 1, if your degree is 1, okay, if your power is 1, we call this as a linear equations, linear polynomial. Okay, so constant polynomial, if I talk about the example, if I talk about this example here is 7, 8, 1, minus 2, these are pi. Okay, these are all constant polynomials. Okay, now when you talk about the linear polynomial, your degree is 1, almost degree is 1. Okay, and it's called as a linear polynomial, and it's almost depend their general equations. Okay, general equation, you write this one as a ax plus b equal to 0, where a should not be equal to 0. That means what? Our a should not be equal to 0, b may be 0, but our a should not be equal to 0. Example, if I discuss about some example like ax, not ax, I'm sorry, 7x plus 2 is also a linear polynomial. Why? Linear polynomial, why? The degree here is 1. Okay, and here the 2 is a constant number. We know constant number means the degree will be 0. The degree will be 0. So this is a linear equation. Okay, or 7y, this is also a linear equation. and Lx, okay, Lx is also a linear equation. Lx plus 3 is also a linear equation. What? Their highest degree of the polynomial is what? 1. Okay, so one thing I forgot to explain is what? When do we say the polynomial is what? When do we say the equation is a polynomial? The equation is said to be a polynomial if their degree, the equation is said to be a polynomial if their degree are a whole numbers. Okay, if the degrees are a whole number, means if I talk about ax 2 plus 3 3x 5 plus 7x 1, this is a polynomial. This is a polynomial. Why? Because this is the power is 2 here, the power is 5 here, the power is 1 here, and this types of equation is called as a polynomial. And this all these 2 5 1s are what? 2 5 1s are what? It is a, their degrees are what? Their degrees are what? It is the whole number. Their degrees are whole number. If the degree is a whole number, we say then this equation is a polynomial. But if I say the degree is something like this, ax to the power 1 by 2, the degree, this is 1 by 2, it's not a whole number. Why? This is the fraction. Okay, this is a rational number, so such types of equations cannot be expressed. Or 2x cures, okay, or plus 3x. So we cannot say these types of polynomial as this types of equation as a polynomial. Why? Their degrees are half. Okay, their degrees are half. This is which is not that. If you just know that real number. Or if you say x to the power root over x, it is also not a polynomial. Okay, if I say y to the power 3 by 2 is also not a polynomial. If I say x to the power minus 0.03 is also not a polynomial. Why? All this degree, if you check about the degree in this equation, their degrees are not a whole numbers. You know what is whole number? The whole numbers are those numbers, okay? Those integers starting from the 0, okay? 0 to infinite, starting from the number 0, 1, 2, 3, 4, 5, keep on going. So such types of numbers are considered to be whole numbers. Okay, so this is all about the polynomial. Now we have discussed about the actual meanings of the polynomial. Now we have also discussed about the degree of if the degree is 1, the linear, this is a linear polynomial. If the degree is 2, okay, if the degree is 2, we call this as a quadratic polynomial. Okay, quadratic polynomial. If the degree is 2, then this is a quadratic polynomial. Their general statement we used to write, their general equation we used to write, ax cubed plus bx plus c is equal to 0, where a should not be equal to 0. Like example, if I talk about example like 9x cubed plus 3x plus 2 is also a linear equation. It is also a quadratic equation. Why? The power is 2 here. The highest power, the highest degree is almost 2. The highest degree is almost 2. Then such types of equations are considered to be the quadratic polynomial. Okay, next we have another degree, that is a degree is equal to, if a degree is equal to 3, then such types of equations are considered to be the cubic polynomial. Such types of equations are considered to be the cubic polynomial. And for these equations, our ax cubed plus bx cubed plus cx plus d is equal to 0. Here you see our highest power is what? Highest power is 3. It is 2 is also there, 1 is there. So according to degree, these are some standard that you have to remember up to the class 10. Okay, if the degree is 0, we consider them a constant polynomial. Constant polynomial like number 1, 2, 3, 4, a real numbers, okay, a whole number, natural numbers, irrational numbers, all are constant numbers. So such types of constant numbers have a degree of 0. If the degree of have a 1, so such types of polynomials are called as a linear polynomial, and their general statement we read it with x plus b is equal to 0, where x should not be equal to 0. Okay, similarly here quadratic equation is what? A quadratic polynomial is what? Quadratic polynomial is the power is the highest degree is 2. Okay, the highest degree is 2, so such types of polynomials are considered to be the quadratic polynomial, where a should not be equal to 0. Okay, the cubic polynomial is what? If the polynomial have a highest degree 3, okay, if the polynomial have a highest degree 3, so such types of polynomial is considered to be the cubic polynomial, where a should not be equal to 0. Okay, this is all about the polynomials. Okay, now we will be talking about, now here we will be talking about another polynomial, the value of the polynomials, value of the px. Okay, value of the px. Let's say px. Okay, we are giving the polynomials of x, polynomials of function x, that is 6x cubed plus 7x plus 3. Okay, so this is what we are giving. Now you are trying to find out the values. Okay, we are trying to find out the value x is equal to, let's say, 2. Okay, now if I put the values of x is equal to 2, then you are going to get some values. That is 2 in place of x, we are going to put it. Okay, so this is what you are going to put it, that is 3. Okay, so when you put this 6 into 2, it become 2 to the 4 and 7 into 2. Okay, plus 3. Now calculate 6 4s are 24. 7 to the 14 plus 3. Now add up these two, that become 38 plus 3. Then its total answer is 41. So this is the value of the polynomial when x is equal to 2. Okay, this is the polynomial. This is the value of the polynomial when x equal to 2. Okay, or x equal to any values if you put, and if you put x equal to any numbers, if you put x equal to any numbers, and you are getting the values of the polynomial. So such types of values are called as the values of the polynomials. On the basis of this value of the polynomials, we will be discussing zero of the polynomials. Okay, zero of the polynomial means what? Zero of the polynomial. We are going to discuss about the zero of the polynomials. Okay, zero of the polynomial. What is zero of the polynomial? Zero of the polynomial set. Whenever you are putting the values of x, okay, whenever you are putting the values of any values, let's say we are putting any values that is k, and if you're putting the values of any values, k may be any values that is 1, 2, -1, 3, whatever it is, okay, you are putting any values of 0 or k, okay, x is equal to any values here, and you are getting the answers, your entire answers is equal to 0, and such types of equation is considered to be 0. Okay, such types of value is considered to be the 0 of the polynomials. Okay, in this chapter number 2. Then when you discuss in the chapter number 4, we used to consider them to be the root of the polynomials or solutions of the polynomials. Okay, so solutions of the polynomials or root of the polynomials. Okay, this is what we used to discuss. Now let me discuss. Let me give some example again here. Let's say px is equal to what is it? X cubed. Okay, x cubed minus 9. Okay, x cubed minus 9. Now if you put the values of x is equal to 1, x is equal to 1, surely the px will be what? That is 1 minus 9, that is equal to 1 cubed is 1, minus 9 is what? 8, minus 8. Then x is equal to 2, what is it? X is equal to 2, you put it, x is equal to 2, that means 2 cubed minus 9, that is equal to 4 minus 9, that becomes 5, minus 5. Now if you put x is equal to 3, that's equal to p squared is equal to p in place of x, you are putting 3. So 3 squared minus 9. So 3 is a 9 minus 9, that become what? 0. So this, if you put the values of x is equal to 3, x is equal to 3. Okay, when x is equal to 3, if you put the values in the equation, that means what? Your answers become 0. Okay, that means what? This is what? This x is equal to 3 is the 0 of the polynomial. It's the 0 of the polynomial. That means this is the complete solutions of the polynomial. Okay, this is the complete solutions of the polynomials. Okay, that is what we say, 0 of the polynomial. We say whenever you put the values, any values of x in any polynomial, you are getting the entire value as a 0. Then such a value is considered to be the 0 of the polynomials. Okay, so now we are going to discuss about the geographical meanings of the polynomials. Okay, now whenever you are given the equations, mostly our quadratic polynomials, you see in class 10 you will be discussing mostly on the quadratic polynomials. Okay, quadratic polynomial, what is it? Whenever we discuss on the geographical polynomial, we know that this is an x-axis and we know this is a y-axis. Okay, you are giving some equations, and if this x-axis, your equation is something like this, it is touching the values. Okay, this is something like this. Let's say px is equal to x cubed plus 3x plus 2. So this equation is touching the x on this one point and this point. That means these are two zero of the polynomial in terms of the what is it in terms of the geographical means. Okay, in terms of the geographical meanings, we say if this graph, okay, the parabolas, if the parabola is touching the x-axis, if the parabola is touching the x-axis, that means this have a 2 0. What is it? In which point they touch? This is a 2 0. If it touch only in one point, let's say this is the one, another geographical, another polynomial, then this is touching in this point. That means this is touching not here. This is touching in this x-axis. That means this is only one polynomial. If it doesn't touch, okay, if it doesn't touch here from there, that means it doesn't touch in any axis of the horizontal axis of axis. That means they don't have any solution. They don't have any solution means they don't have any zero of the polynomial. They have non-zero polynomials. Okay, they are non-zero polynomials. That is what we can consider in the geographical meanings of the geographical meanings of the quadratic equation, quadratic polynomials. Okay. So here we will discuss about the exercise 2.1. Here exercise 2.1 question number B, number 1. Okay, here you asked to find. You see the question said, okay, your question said the graph of y is equal to px are given in the figure 2.12 below. For some polynomial px, find the numbers of zero of the px in each case. Okay, so these are some graph I have just taken out. Some graph, okay, graphically I have taken out. This is number 1 graph, number 2, number 3, and number 4. Okay, so in this graph you see how many zeros are there in this polynomial. There's no zero. Why? No zero of the polynomial. No zeros are there. Why? Because this graph, this line is not touching on the x-axis. That means they have no solution. Okay, for this graph we don't have any solution of it. Now if I talk about this one, here you see our graph is going in this direction and touching the x-axis at one point. That means they have only one 0. Okay, 1 0 of the polynomial. 1 0. Okay, 0 is what? How many? Only 1 zeros. Okay, only 1 zeros of the polynomial. Only one solution we have. Only one solution we have. If we talk about this one, if I talk about this one, we have 3 point touching the x-axis. 1, 2, 3. So 3 point we are touching the x-axis. That means we have 3 0. How many 0? 3 0. We have 3 zeros. Okay, we have 3 zeros. Now when you talk about this one, 1 and 2, we have only 2 points. That means what? How many 2? 2 0. How many 0? 2 0. Okay, how many 0? 2 0. We have a 2 0. That means x is equal to some values, x is equal to another values, which this equation will give you the values of 0. Okay, so this is our Roman number 5. Okay, this is our Roman number 5 and this is our Roman number 6. Okay, this is our Roman number 5 and this is our Roman number 6. So when we discuss about this one, how many zeros we have? This graph is touching the x-axis at this one point. 1, 2, 3, 4. That means what? 4 values we will get from here. 4 values we will get where your equation will become 0. That means we have a 4 0. Okay, we have a 4 0 of the polynomial. Now when you talk about this one, 1, 2, 3. Okay, how many? 3 0. Okay, so 3 0 of the polynomial. We have only 3 values. That means 1, 2, 3. Where this x is equal to at this point, x is equal to this point, x is equal to this point, where your answer will become 0. Okay, where your answer will become 0. Or we can also understand, you see, whenever we have a values of like, whenever you are trying to draw the graph y is equal to x is equal to 0 or x is equal to 0 and y is equal to 1, that means our graph reaches here. Our graph reaches this point, and then this means 0 means what? The x is lying on this horizontal point. Okay, x is lying on this horizontal point. That means what? Whenever the graph touches the point, and we are talking about the x-axis, okay, we are talking about a quadratic equation, then how many lines does it touches? Okay, now let's discuss about this equation. One more equation. Okay, some additional equation. Now let's talk about this one more equation. Let's discuss this one. Okay, so what do you say this one? Okay, what do you say? How many points does it reaches? Okay, now here you see we have 1 point touches here, 1 point touches here, another 1 point touches here. That means how many solution? 3 0 we will get. How many 0? We will get 3 0. Okay, so this is all about today's class. Okay, from tomorrow we will be discussing about the relationship between the zero and the coefficients of polynomials. Okay, in the next video. Thank you.